Hi folks, we're going to be doing 10.4 inscribed angles for geometry. And so one thing we're going to go through is remember what a central angle is. So if we have a circle right here, we have center of the circle. A central angle has a vertex in the center of the circle and sides that contain radii of the circle. So a central angle might look like that. Now we've been talking about those, and so we know that a central angle, the measure of a central angle, is the same as the measure of the arc. So if this angle was 30 degrees, well then the arc is also 30 degrees. The new vocabulary word we're going to learn today is inscribed angle. So an inscribed angle, let's draw it. Let's go right here. There we go. It's an inscribed angle. And this angle has a vertex on the side of the circle or on the circle and sides that contain chords. So we have a central angle and an inscribed angle. So there are going to be 4 different theorems that we have about inscribed angles. Our first theorem, so our theorem 1, is that if we are given a circle and we have an inscribed angle right here, let's call this A, this will be B, and this is our angle right here. Let's call it angle 1. So the measure of angle 1 is going to be equal to 1/2 of the measure of arc AB. So unlike the central angle, that was if this was 30 degrees, that was 30 degrees. If angle 1 is 30 degrees, AB is 60 degrees. Or the other way around, if we are given AB is 60 degrees, we're going to divide that by 2 to find the measure of angle 1, which would be 30 degrees. Let's do an example on this. Our example 1, if we have a circle, and we're going to do 2 different inscribed angles. See, this will be Y, Z, and X, and not to be confused, this will be W over here, not to be confused with A. All right, this arc is 86 degrees. The inscribed angle is 52 degrees. We want to know the measure of X, all right, measure of angle X right here, and we want to know the measure of the arc YX. So measure of angle X is going to equal 1/2 times 86. 1/2 times 86. That means measure of angle X is equal to 43 degrees. So we also want to figure out the measure of arc YX. Measure of arc YX, we have 52 degrees, so that means this is double that angle. Measure of YX, we're going to do 52 multiplied by 2, which is going to equal 104 degrees. All right, theorem number 2. Theorem 2, if we have 2 inscribed angles, so I'll draw the circle right here. If we are given 2 inscribed angles and they intercept the same arc, so we have arc DA here, if point C and point B intercept the same arc, so C intercepts D, we have CD as a chord and CA. We also have BD and BA. If that is true, that means that these two angles are congruent. So if C and B both have chords that intercept DA, angle C is congruent to angle B. So that is our theorem 2. Let's say, for example, angle C, so if angle C is equal to 12x minus 13 and angle B is equal to 9x plus 2, and I said solve for x, because these two intercept the same arc, that means we can set them equal to each other. We would set 12x minus 13 equal to 9x plus 2, and we would solve from there. So we would get the answer then of, let's say, 3x equals 15 and x equals 5. If we wanted to, from here, actually find out the measure of, let's say we wanted to find out the measure of angle C, we would plug that 5 back in for x, and 60 minus 13 equals 47 degrees. So you're able to find out many things about the angles in this circle just from knowing that angle C and angle B are congruent to each other. That is theorem 2. All right. Theorem 3. So theorem 3, if we have an inscribed angle in our circle, here's a circle. If we have an inscribed angle that intercepts the diameter, so here's our diameter, and our inscribed angle, I'll go point G here. If that intercepts the diameter, that means that angle G is 90 degrees. It is a right angle. So we'll go F and H. So our theorem can be written out if G intercepts the diameter, angle G equals 90 degrees. Now, from this theorem, there are two different things that we can find. We can find the lengths of the sides because all right triangles match the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So if we are given two of them, we are able to find the other one. If we're given an angle on either one of the acute angles here, you can use trigonometry to find the other side. Also, if you are given one of the angles, that means that, and you know this is a 90-degree angle, you can find the other angle because all triangles equal 180 degrees. All right, our last theorem, theorem 4. Theorem 4 is about quadrilaterals that are inscribed inside circles. So if a quadrilateral, let's say we have a quadrilateral right here. We'll go L, M, N, K, so KLMN. And let's see, this is circle A. So if the quadrilateral is inscribed inside a circle, its opposite angles are supplementary. That means angle M plus angle K equals 180 degrees. It also means angle L plus angle N equals 180 degrees. And so you are able to find angles based on this theorem. For example, if you were given that, let's say this is 14x degrees and angle K is 8x plus 4 degrees. If you wanted to find x, because that's what we always do in geometry here in algebra, find x, there it is. We're going to actually add 14x plus 8x plus 4 and going to set that equal to 180. So if we wanted to then solve this, we'd solve, and I'm not running out of space here. I've actually solved this on another sheet of paper over there, but we have x equals 8. And we could actually, let's say we wanted to find angle K. So measure of angle K, we would plug 8 back in. 8 times 8 plus 4. Well, 64 plus 4 is 68 degrees. And so those would be our 2 answers for that problem. All right, that kind of sums up 10.4. So there you go, if you need to take a screenshot or anything. And I hope that you have a great night.